All right, I believe the sixth item on my list is testing. And the reality of software development is that we spend most of our time doing this. So any language that doesn't include a system for effectively testing is like missing something important. Go has its own built-in testing package, and you can extend it. It has lots of features. Now, when you build a test, what Go actually does is it writes a main program for you on the fly, and it calls the tests. Okay? So the testing package is just a library in Go, and you are expected that when you have some file name, like XYZ, if you put test.go, that is not a part of the actual code that you want to compile for something, that what is in there is in tests. And the test files get parsed, and it calls all of the tests in each file when you do Go test. So if you do Go build, it skips those. There are also example files that it will compile but skip. Okay? And so you don't want to name things test unintentionally at the end of your file. Now, my convention is I always name it _test because it stands out. So if I have an XYZ package, I probably am going to have an XYZ _test file in there. Now, there's nothing stopping you from having, the same thing going on in your main package. If you've got stuff you want to test in there and do unit tests on it, you can have main _test. And you put tests in it just like any other package in existence. I have seen every once in a while people just literally standing on their ear to get around testing of their main program. You don't have to. You just create the test and move on for your main program. Easy. I think they do that because they just don't realize that they can have a test of a main program as the main module. So, what do we do if we want to have some sort of a package and we want to test it? Now, we need to create a package. So you've got some directory path that you're working in. Go, github.com/ whatever your name is. Okay, we'll have Mike be the name this time. And you've created some package, P1. And underneath P1, you have some package. We'll call it test1. So inside this, we have a file called test1. Notice the test is at the beginning, not at the end. There is that one there, or I would have problems.go. And inside it, we have package test1. And we've got some function in there. Function AA, okay, that takes a parameter n of int, and it returns an integer. So when we return an integer, you notice I've listed the returns out over here. You can put more than one return. You just put the types of each one of them. There are other things you can do out there, but here we have a function, and let's say that it takes n times 5, and it returns that. So we want to do return of, you don't need the paren there. Okay, too many years of Go or C programming. N times 5, and that's what it does. So we want to make certain that our 5 times function actually works correctly, and we have put it in its own package. We've created a new package that isn't main, which means that in the main program, I can now do import. Okay. And parentheses. And underneath import, I can say github.com/ Mike was who we did here. Mike / and our package was P1, our top package, and we can have this other package test1. And then inside my code, inside the main function or in some other function, inside the main package, I can say test1.aa of 4 and expect to get back 20. So this gives us one piece of the picture on how we would go about doing, here's the package, here's a sub-package, here's how I reference the package, here's how I reference a function in it. This isn't how you test it, but here's the layout for multiple packages that you can put together yourself. Now, most of the time in the land of Go, what we do is we want the packages to be logical, coherent pieces. And we want each file to represent one kind of thing in a package. So, for instance, there is a package called HTTP, which has all the stuff for interfacing to the web. Clients, servers, WebSocket stuff, proxies. So there's a bunch of different things. So if you want to go and look in the source code for that package, you would expect to find all the functions having to work with being a client in the file named client.go. And we don't stick one little tiny 4-line thing in a file. We stick all the stuff that logically goes together in a single file. So client.go is a couple thousand lines of code. And when we look at servers, there's servers and the different pieces of servers, and it's actually split out over several files. But they're all named together, and they're all about 5,000 literally lines of code in 4 files. So the types, the way they're used, all of that stuff goes in a single file. Go also has Go doc, which if you look at the documents, you do something like you go to Google and you type in Golang. Don't type in Go. Use Golang, you'll get better results. Golang HTTP server. And it will take you to some documentation on Go. Good documentation. But the documentation is all in the source code of the files as comments. And GoDoc is a way of taking stuff in source code and turning it into good documents that you can then publish on the web. So all the pieces in a package can easily be turned into good documents on how it all works together. And that's a useful piece of it too. There are examples and example code built into the language. Remember I said tests? If you end stuff in example, then you're building example code. Those pieces of example code also are things that it will compile, but it never runs and it doesn't include it in your executable. Which means your examples have to be syntactically correct or they won't compile. Now, they don't take up any space in your executable, but this means that if you change something inside your library and you don't change your example, it will break and you will fix it because your code won't compile. So they do some things like that to make certain you've got all the pieces working together. Now, I'm going to take this instead of in a main program and put it in the context of a test. So I'll save this on here and then we're going to write a test over here. Now, I'm going to use the same package as we did here, test 1. Okay. There is a special feature in Go so that you can only access external interfaces in a test. Then you use a different package name. You'd use package test1_test, which is different from this, but since these are the same, you have access to internal stuff in here if you want to do unit testing on internal functions. And you want to import testing. And you create a function that you're going to have called. There is a special parameter called t, normally. That's the default, or it is what is commonly used in all the stuff from this package. And the example I give you is a more comprehensive example than what I'm going to write up here, but we could just say if AA of 3 is not equal to, that is a not equal, not a colon equal, is not equal to 15, then I want to fail my test, so I want to do t dot error f, and I want to print out some useful message like oops I hope you use better messages than that, but I don't have much room to write here on this thing, on this light board, so we're just going to print out oops. And that is the end of the function. And then in your code, when you run it, all you have to do to run all the tests is you do go test. And it will print out pass, or it'll print out the errors that you got from this. Now, having the ability to have testing built into the language, and the example that I give you in the homework is much more comprehensive, but this is a huge piece in terms of getting code correct. And let's face it, broken code isn't worth anything, whereas working code does something at least, so this is an important thing. Now, in this class, I'm going to be supplying you with tests for all the modules that I supply you with code. And one of the ways that you can determine how stuff works is by going and looking at the tests. So the tests are an important piece of the documentation of how something works. So if you want to look at how I store blocks, okay, in a blockchain, there's a test in there that goes and stores a block and retrieves a block. And you can see what the parameters are, how they're called. You know, it's not just that the tests pass. It's also go and read the code and look at it and go, oh, I see that there's actually 6 parameters to this function. And yes, I know it was in the documentation, but when I actually go and look at it, I can say, this is how I call it, and I'm going to grab that piece of code right there out of the test. I'm going to copy that into my stuff because that's what I need to do at this point. So testing is important for usage as well, and documentation. And let's see, what else have we hit on here that we didn't talk about before in this language? We had a data type up here that's in a package that's imported. So we imported testing and we used the data type. It is a pointer. That's what this little star is right here. For those of you who have not programmed in C code, these \n means go to a new line. There is \r, which is carriage return and brings you back to the beginning of a line. There is \f, which is a form feed character, which if you're printing stuff sends you to the top of a new page. And there's \t, which is a tab. Those are important things to know. And if you want to put a backslash in a string itself, you put in \\. So those little guys right there, inside strings. Now those are double quoted strings, which are strings. If you use single quote, that is a rune. Okay. And if you use backtick, it is a literal string that can span multiple lines. So if it's on multiple lines, it has \ns in it. Now, Go has the ability to process constants at compile time. So there's no cost to concatenating strings that are constants. All that happens at compile time. It doesn't happen at runtime. In fact, Go will calculate any static expression at compile time. The last note on Go things that is different than every other language that I have ever seen is the variables determine the typing of an expression, not the constants. So if you put 1.0 plus a variable that's an integer, that 1.0, which is a float, got converted to an integer at compile time before the expression was ever calculated. It's not like you can say 1.0 plus an integer and expect to get a float. You don't do that. At compile time, constants are converted to the types of the variables. And that is throughout the language. Also, all of these things have data types that are strictly enforced. So if you have an int 64, you can't assign it to an int without a typecast. No exceptions. All the types in the language are strictly enforced. And you would think that that would show up more, but because all of your constants, like 3 here, 3 is a number, but it gets converted to the type of the variable int over here, okay, and that happens at compile time. Which means if I had taken that 3 and I had passed it to an int 32 or an int 64, you wouldn't have seen it. It would have happened at compile time and you never would have noticed. Okay, so that is kind of how you write a test in a package. And we'll move on to the next subject. But at this point, you know, you've gotten enough in this language that, yeah, you're probably getting close to, you can write some pretty decent programs.